Equations with variables on both sides. Equations with variables on both sides. Let's start off with a thinking map. Here we are. Going to make a nice big thinking map, just 3 branches. This thinking map is called types of equations, types of solutions for equations. You're going to be held responsible for 3 types of equations. Equations with one solution, equations with infinite solution, and equations with no solution. Can you imagine that? There's actually equations with no solution, where you can't get the variable by itself equaling a number. All right, so what would an equation with one solution look like? Well, let me give you an example. Yeah, the one like Warmer. I'll just do a simple one here. So I'm going to just make up an equation off the top of my head that's very simple and it has one solution. How about x plus 2 equals 10? There's only one number in the entire universe and on all of reality that will be a solution to this equation, that will satisfy this equation. What number would that be? 8. So go to write x equals 8. There's only one solution, and that's it. There ain't no other solution. Let me give you an example of what I'm talking about. Infinite solutions. What if I have x plus 2 equals x plus 2? That's an equation. You have an expression on the left side and on the right side. But notice the left and the right side are exactly the same. So no matter what number you think of, if you replace x with any number you think of, remember our favorite numbers last week? You guys give me your favorite numbers. You replace x with any number, it'll satisfy the equation, any number. But let's just say you didn't recognize the left and right side were the same and you want to get x by itself. Okay, let's see what happens. Let's get x by itself. Let's subtract x from both sides to get added on x on one side, because right now x is on both sides. Look what ends up happening. 2 is equal to 2. You end up with this statement that's true. The variables cancel out. This is called an identity. So we're going to write identity, which means all numbers, all real numbers are solutions. All real numbers are solutions. Now, when I say a real number, I'm talking about any number on the number line. Fractions, decimals, whole numbers, negative numbers, anything. All real numbers are solutions. Okay? So let me prove it real quick. I want to prove that all real numbers are solutions here. What was your favorite number again? So it's just 6. Look at the original equation. I'm going to replace x with 6, and notice how 6 satisfies it. 6 plus 2 equals 6 plus 2. Look at it. Satisfies. 8 is equal to 8. All right, up here. In other words, any number will work. So we call this an identity, this equation an identity. There's literally an infinite amount of solutions to the equation. No matter what number you replace x with, it will satisfy it. So, look at the title of our tree map, types of solutions. Equations with one solution, equations with infinite solutions, called an identity. And how about an equation with no solution? Watch this. Let me give you an example. X plus 2 equals x plus 3. Write that down. X plus 2 equals x plus 3. I'm willing to give you guys, if someone can give me a solution to that equation, I will write a credit slip right now with an A+, and you're done with my class today with an A+. Let's go. Galvan, head up. Go ahead.
I said there is no solution. That's what you're saying.
No, what I'm saying is that if you can give me a solution, I'll give you a credit slip with an A+ and 5 credits. You're done.
But there is no. To that point, right?
She's still talking to. Hold up. Go ahead.
To that problem, right? You're talking about solution to that problem.
I'm saying that, yeah. But I'm also saying if you can give me a solution, you're done with my class today with A+. You go to Mr. Deep, Miss Valerie Cabrales, and she'll process your credits. You're done with Math 1A with an A+.
Yeah, that's what I'm trying to say too.
Oh, you're telling me that's why I'm saying it?
Yeah.
Okay.
That's what you're saying. That.
So then you want to add something? Okay. That's not good. You don't want to talk no more? You're good. Here's what I'm talking about. Check this out. Let's try to get x by itself. Let's see. X is on both sides. I'm going to subtract x from both sides. Let's see. Nice. The x's cancel out. Watch what happens. The x's cancel out kind of like over here. But look at what ends up happening. We end up having this false statement. 2 is equal to 3. That's not like the indicator or the red flag or the alarm, or the signal, so to speak, that you're dealing with an equation that has no solution. There's no number that will satisfy it. Okay? So look at the 3 I'm throwing at you now. Equation with one solution, infinite, you can't even count them, there's so many, and then equations with no solution. And the typical symbol that we use for no solutions it's a 0 with a slash. Kind of scary. Good Halloween symbol there. No solution. Stop. All right. Say again. 7x plus 19 equals negative 2x plus 55. Seven x plus 19 equals 2x plus 55. Negative 2x plus 55, rather. Now, if some of you are struggling with equations and you guys are not that good with equations and you have the mindset, oh, Mungia, there's too much stuff going on. I don't know what to do first. There's too many steps. That kind of stuff. Well, right here on Google Classroom, I put this picture here next to assignment 7. You guys remember last week the 4 steps? They're all right here. They're attached to assignment 7, the 4 steps to solving any equation. So if you're confused at what steps to apply, first, second, third, and fourth, they're all right here attached to assignment 7 on Google Classroom. So here's assignment 7. It's attached right here. It says steps to solving any equation. That's just a little FYI for those of you who are struggling. Let's go ahead and solve for x. There's no parentheses, so we're going to distribute. Actually, we're not going to distribute, rather. Let's get x on one side. So let's do it. First, I'll get x's on one side, so I'm going to subtract. Actually, I'll add 2x to both sides. To the left and to the right. Because when I add 2x to both sides, it gets rid of it on the right and brings it to the left, right? So now we have x's on the left side only. So we want to start proceeding to get it by itself. So let's get rid of the 19 first. And we got 9x equaling 55 minus 19, 36, thank you. So it looks like we're going to have an equation with just one solution here. So x equals 4. Cool. That's something we're used to. Question on that one. So this would be one solution. Now, typically, you don't have to write one solution down, but I'm just writing it for the sake of my lecture. One solution. 4 is the only number in reality that'll satisfy this equation. No other number. Only one. 4 is it. Okay, now contrast that with the next example. Here we go. Example 2. On your notes. 3 times the quantity x plus 2 equals 3x plus 6. 3 times the quantity x plus 2 equals 3x plus 6. So you got this one? You think so? Yeah, I think you're right. So we have to solve it if you know it. You did solve it once you say it's infinite. That's why we can just write there. That's cool. Okay. So Ned already sees something. He sees that this is an infinite amount of solutions type of equation. He sees something. Both sides are the same, huh? Exactly. Look at when you distribute. What ends up happening? Here and here, I have 3x plus 6 equals 3x plus 6. That's the indicator. That's the signal. Reyes and Rodriguez, I have the floor. Thank you. That's a signal that you're dealing with an equation with an infinite amount of solution when the left and right side are the same. But let's just say you didn't notice they're the same. Let me give you another signal of what happens. Let's get x's on one side. Look at it. So at this point, if you can see the left and right side are the same, it's infinite. We're done. But if you didn't see it, let me show you what happens. The x's end up canceling out and bring out the equal sign. You end up having a statement that's true. Look at that. 6 is equal to 6. That's the signal saying, look, any number will be a solution. So I'm going to put all real numbers. You can either write all real numbers as your solution, or you can write the word identity. Either one's fine. Press.
Why not? Instead of putting 6 equals 6, x equals.
You could do that either too. It wouldn't be x equals x, it'd be 3x equals 3x, because you'll subtract 6 from both sides. That's fine too. Absolutely. All right. I'm done for now.